Jai Hind everyone, myself Sandeep Yadav, Assistant Professor CSC Department. Today I am going to deliver a lecture on Relational Algebra, which is part of DBMS, a subject that is being taught in 5th semester as well as open elective 6th semester. So today we are going to discuss about Relational Algebra. Let us see the outline of the various topics that we have to study in Relational Algebra. First we are going to study selection, then we are going to study projection, then we are going to study Cartesian product, join, set operators, division, rename, aggregate functions. Now we will start with relational algebra. Now first operation, first of all we should be aware what is relational algebra. First of all, relational algebra is a procedural language that is which specifies relational algebra is a procedural language that is it specifies what tasks are to be performed and how to perform the tasks, whereas there is relational calculus also which specifies how to perform the task, which does not specify what part, that is only how part, that is non-procedural, whereas relational algebra is procedural. So now relational algebra itself has several operations. First are the basic operations and second are the extended operations. The basic operations basically are set related operation, union, intersection, difference. These are the fundamental operations that we have already studied in previous classes in mathematics. Thereafter we shall be studying the various extended operations, selection, then projection, join. These are the extended operations. Now first is selection operation, that is denoted by symbol sigma. Now notation is sigma subscript condition followed by the relation. Now this operation select tuples from a relation that satisfies a given condition. This tuple means rows, that is given a relation, if we want to find out certain rows based on certain condition, then we are going to make use of selection operation. For example, we need to find out the detail of the students who lives in city Ghaziabad, then we will be specifying sigma denoted by the condition is city equal to Ghaziabad followed by the name of relation followed by the name of the relation, that is student. Then we will be getting the required tuples. Now various operators then that can be used are and, or, not, equal to, not equal to, greater than, less than, not equal to, less than, equal to, and so on. Now we want to find out the detail of the student who belong to the civil engineering branch. This is a table which consists of the following data. Roll number is there, second is name, third is branch, and fourth is SPI. So in all there are 4 columns, that is the cardinality of this is 4, degree is 4 and the cardinality is also 4 because 4 rows are there. Now we need to find out the detail of the student belonging to civil engineering department, that is the condition is branch equal to civil. So how to do that is sigma branch equal to civil followed by the name of relation, that is student. This is how we will be writing the queries. So that will provide the following answer: 101 Raju civil followed by SPI student progress indicator. Next, display the detail of student belonging to civil engineering branch and having SPI more than 8. Now this consists of 2 conditions, that is we are having the 2 conditions. First, the branch should be civil engineering and second SPI should be more than 8. That is this, again this is the table. Now we have to write the query in relational algebra. So how to write it? See, first we need to specify the first condition, that branch equal to civil engineering, and thereafter we are using AND operator and SPI greater than 8. Followed is the name of the relation, that is student. So in this way the query will be fetching the answer, and what will be the answer is this one is the answer. 1014, then name is meet, civil engineering, and SPI is greater than 9. This one is the answer. This one is not the answer because we need to have the SPI greater than 8. So all the selection criteria are satisfied in the answer, hence the answer is correct. Now again we need to see one more query, that is display the detail of the student who belong to the either CI or ME branch. Now again the table is specified, we need to write the query in relational algebra. How to write that query is, this is how the query is being written, branch equal to CI and branch equal to ME. This is how we can write. Now we want to find out the detail of the student Raju. Next query is, we want to find out the detail of the student Raju. Then how to write the query is, phi name equal to Raju followed by the name of relation, that is student. This is how we can write the query using relational algebra in using the operation selection. Actually what selection does, it divides our tuples into two sets, that is it perform the horizontal partitioning, that is two sets horizontally, that is row wise partitioning is being done. Now we need to display the detail of the student whose SPI is between 7 and 9. Now this query involves the values between 7 and 9 using the selection operation. So this is how we can write the query, that is SPI should be greater than 9 and SPI should be less than 9. So SPI has to be greater than 7 and less than 9. So that will give the answer, that is 8 SPI is the answer for this particular question. Now all these queries that we have studied so far fetches all the attributes. Suppose we want to fetch a particular attribute, we want to display a particular attribute, one attribute or more than one attribute, then that operation is, that selection operation is not up to the mark. It will not fetch you that particular attribute that we want. Suppose we want to show the name of the student. So how to show the name of student? We want to display the name of the student table. Then we are not going to be displayed using the selection operations. Then we need projection operation, that is done by projection operator, that is denoted by the symbol pi. Now the notation is pi attribute set followed is the name of the relation. Now this operation selects specified attribute of relation. It removes, this particular operations remove the duplicate tuples from the results. Now we have to display the roll number only. Now first of all, see, we just want to display the roll number. So how to denote? Pi roll number, and this is the relation student. This is how we can show the roll number. Now next we will write to show some more attribute. Now we have to display student name, roll number and branch. Now how to write the query is pi roll number, name, branch followed is the name of the student. Now that will provide you the following output. Clearly we are getting the values column wise, that is we are performing the vertical fragmentation. We are dividing our original relation R into set of two tables, one those which meets the condition and one those do not meet the condition, that is we are dividing it vertically. That is why it is said to be performing vertical partitioning. Now we have to combine these operations, both select as well as projections, so that we can have the desired output in good manner. Suppose we want to find out the name of the student whose roll number is 12. That means we need to find out the particular attribute and we have also one relation that specifying the condition that roll number equal to 12. Then we need to combine both operations. Now we need to see the following query: display roll number, name and branch of mechanical branch student. So we need to display these things. So these things can be displayed by pi, and this is the condition part. So we need to combine both operations. Now we will see how to write the query for this. Step 1, first we will be specifying the condition that branch equal to ME, that is this one. Second, we need to specify what attributes we require, that is pi, roll number, name and branch. Condition is branch name equal to ME, and thereafter we shall write the relation name, that is student. Now again one more query: display name, branch and SPI of student whose SPI is more than 8. Now again this part is again specify the condition. And this part is specifying the attributes. Now condition is SPI is greater than 8, and what the attribute that we want to show is, now attribute that we want to show is pi, name, comma branch, comma SPI, where SPI is greater than 8 and the name of relation is student. In this way we will be able to fetch the required answer. Now one more query: display name, branch and SPI of student who belong to civil engineering branch and SPI is greater than 7. So this query involves both selection as well as the projection. In selection operation, now there are more than one condition, and is used for that condition. Now first write down the condition, that is selection operation, branch equal to civil and SPI greater than 7. Now we will be appending before it is project operation, that is pi, name, comma branch, comma SPI and sigma branch equal to civil and SPI greater than 7, and thereafter we shall be writing the name of the relation, that is student. So in this way we will be getting this particular output. One more query, that is pi, name, branch, then branch name equal to mechanical or branch name equal to CI, that is follower is the student. Here we are using or instead of and, here we are using or, that is why we are using or operator. Either the student may belong to this particular branch or this particular branch. Now next is Cartesian product, a simple operations that we studies in basic mathematics up to 12th standard, that is Cartesian product, that is relation R1 cross R2. It multiplies each tuple of relation 1 to each tuple of relation 2. Now attribute of resultant relation equal to attribute of relation R1 plus attribute of relation R2. Tuples of resultant relation R equal to tuples of R1 into tuples of R2. Suppose R1 has 3 tuples and R2 has 4 tuples, then total number of tuples in the resultant equation will be 3 cross 4, that is 12. Now let us do the cross product between two relations, student and result. Following are this. Now the answer will be this one. Now if both relations have some attribute with same name, it can be distinguished by complying the relation name dot attribute name, right? Now this is how we are doing. 101 is combined with all these things. Now here we are specifying before roll number, we need to specify this roll number comes from which table? Student table. So here student is appended before this roll number, and here also this roll number is coming from result, so that is appended before this one. Now 2 into 2 is, that is 4. This is way how we will getting the answer. 101 Raju CE 101 8, then 101 Raju CE 102 9, and so on. In this way the Cartesian product will work. One more example of cross product between student and result. Now consider only selected attribute, roll number, name and branch from first one, and roll number, SPI and BL from second. So that will be giving the answer in this form. This is the answer. Since we have considered only following, only these attributes are being considered, so the query will have only these particular attributes in the answer, and roll number is common in both of them. That is why the table name is prefixed before the roll number. Now as such, this operation is useless since it shows all the combination and permutations. That is why it is not used commonly. Next is inner join, that is denoted by the symbol join operation. Notation is relation R1 join R2 or algebra 1 join algebra 2. Suppose our query fetches data from more than one table, then we need the join operation. The purpose of having the join operation is to fetch data from more than one table. If the data is being fetched from more than one table, then we need to use the join operation. The first operation is natural join. Natural join will retrieve consistent data from multiple relation, that is more than one relation. It combines record from different relations that satisfies a given condition. The steps performed in natural join are: first is it performs the Cartesian product, then it deletes the inconsistent tuples, then it removes an attribute from duplicate attributes. This is the how that steps are being done. Now perform natural join between student and result. Now we have to perform the natural join for this particular tables. Let us see how to perform them. Now student, then natural join result. This is how we are showing. Now following is the answer of this particular natural join. Now first how we got that particular answer. For that, first we need to perform the Cartesian product. Thereafter performing the Cartesian product, we need to eliminate the inconsistent tuples. Now removing the inconsistent tuples. Now inconsistent tuples we have removed. See, this Mitesh is not 101. We need to remove it. Mitesh entry need to be removed. These are inconsistent tuple, and that SPI of Raju is 8, not 9. So this is also inconsistent. So these three are inconsistent. That is why we need to remove them. Next step is, after removing the inconsistent tuple, we need to remove the duplicate tuple. That is, this roll number is here also, this roll number is here also. So we need to remove one duplicate, that is roll number is duplicate, since it is repeated 2 times, so it will be also removed. And this is the final answer: roll number, name, branch and SPI. Now need to perform the natural join between branch and faculty. The two relations are given and we need to perform the natural join. This is how output will be like this only: BID, BName, HOD FID and FName. So this is how the query can be executed. Now this is repeated. So we need to remove one entry from here. To perform a natural join, there must be one common attribute. This is the common attribute. It's BID here. Now we are being given certain relations. Student relation is there, department is there, academic is there, guide is there, faculty is there. We need to find out the list of a student with their department name and SPI of all students who belong to the C branch. So student name is present in student relation, department name is present in department, and SPI is present in academic. And the student belong to which department? C department. So the query involves fetching data from three tables. That is, we will be fetching the data from three tables, that is student table, department table and academic, and the condition is department name equal to civil engineering. This is how we will be writing the query. Now what attribute we want to find out? S name, D name and SPI. Condition is this one and the data is being fetched from these tables. So this is how the clear cut complete query will be written. Steps we need to remember. How many tables we require? We require three tables. We will be using join operations. Condition is being specified here, and before specifying the condition we need to specify which particular attribute we want to show. We want to show the student name, department name and SPI. Now display the name of student with their project name. Now project name is being presented with whose guide is AJ Shah, right? The project name is presented in guide and guide is AJ Shah. So how to write that query? First, what we want to display is we want to display the student name, that pi student name, followed by the name of the guide. Guide name is present in guide table, student name is present in student table, and faculty is AJ Shah. So where is the faculty name? The faculty name is in this here. So we need three tables: student table, guide table and faculty table to get the desired output. I hope all of you are now clear with the basic concept of selection, projection and natural join. Thank you everyone.